Hello. In some of my previous videos, I have shown you how you can perform a firmware update using our backend by utilizing this UDP Proxy script, which is written here in Python. We have recently created a Go version, because Go is a compiled language, so it is much more performant, and it can be basically there permanently during runtime of your backend software without causing any extra overhead on your server. That's one thing we have done. And another thing is that if you communicate like this, and if our ACRIOS backend update software is running on a different computer, and this is not a private link but a internet connection, it is susceptible to any kind of attack. So what we have done, we have modified this UDP proxy service so that it uses Wireguard connection, and it is now possible to start this. It will create a Wireguard connection, and all the traffic is then routed through this Wireguard connection, and the firmware update happens. So I will now show how this can be done. Here is the backend. I have prepared some. I have prepared already some examples. So here is the ID we will update. Here is the name of the firmware I have before uploaded to the backend, and here we can see the log of the communication later. But before performing this, I will show you how the UDP proxy looks like. So on one server we have the proxy. On another server we have I have called it a fake application server, but basically it's just a Python script which receives this basically simulates a customer's backend. Yeah, so it receives data. From the updater and prints them out. And also I will show the co-implementation of the proxy. So this will be available to you on request if you want. What it does is that it filters the data traffic. This is only sent to the application server. There are so-called beacons, which are used to have information about whether the device is alive or not and what's its status. And this communication is routed both to the application server and to the updater. And then there is communication related to the firmware update, and this is only routed to the updater and not to the application server to interfere with normal data. So here is how the filtering is done, and then the data is either sent to one or other or to both servers. Okay. Here is Docker Compose for the setup. So the proxy needs this capnet admin because it creates a VPN connection. Here you define the client key and server public key. Ask us for obtaining these keys. Here you define the IP address and port of the VPN connection to our ACRIOS backend, and this is the command line argument for the UDP UDP proxy in Go. This means it listens on all interfaces, but basically, thanks to this port mapping, it listens on the IP address of the server where it runs. This is the IP address of our ACRIOS backend inside of the VPN. This is IP address of the application server. I am running it on a different server, but it can be also inside the same server, inside the same Docker Compose group of services, for example. And this last thing is a range of ports which is used during forwarding of the traffic to the ACRIOS updater service. Okay, so now I will start it. So it will be Docker Compose. I will first put it down. Okay, now I will start it. Okay, now it's started. We can for example check what's how much it consumes. Yeah, this is the first service, so it consumes really no memory and 0 CPU when it does nothing. But this is not fair. It should be fair to observe it under some load. But just to give you some idea, Go is a compiled language, so it will not be like hundreds of megabytes of memory just for doing nothing, like some scripting languages. Okay, so this is the proxy. I will let it run like this. And this is the fake application server. I will run it as well. And here is on the left upper side is the console of the device which is on the table. So first I will just click and not schedule a firmware update, and we will see what will happen and what will be sent where, just to have an idea what will happen when a normal traffic is present. So we can for example here ask for the log. So the last message was some time ago. Now I can see on the clock it's 16:36, and this is UTC, I think, so there's a shift. So I will click the button, which will trigger sending of data. So we should see the data will be received here, it will be resent here, and it will be also received by the updater. This upper right is basically the updater. This is the application server, and the okay, so I will refresh, for example, here, and we can see that now, yeah, I can see 16:37. So here it was received 14:36:58, and an answer with acknowledge was sent from our server, from the updater. And here is the application server, which also received the beacon. On the proxy, this is the IMSI of the converter, which is here. This is the raw data, and then there's the information that the data was forwarded to these IP addresses. Okay, so this is like a normal what happens when no firmware update is scheduled. Now I will schedule the firmware update. Okay, success, great. And I will clear here, and I will click the button again, and we should see things happening. Yeah, we can check, for example, here. Okay, so the beacon was received also by the application server, and okay, the reset command was sent by the Updater Backend, and now the device starts the update process. You can see here inside of the proxy that the answer of 07 was received from the backend, and it was for this query, and it was forwarded back to the device. Okay, now the we are using the older NB-IoT module for the example, but it should work with both the old and the new one. Yeah, okay. It detected the SIM card. It starts connecting to the network with no power saving mode enabled in bootloader. Okay, and now it already starts to send a lot of data. This is received answer from the updater and sent back, and then you can see here on the upper left side that the data is being received, and an acknowledgement with the checksum is sent back, which confirms that the transfer happened well. And we can check what happens on the application server. Yeah, here you can see it's silent, so no data is received by the application server because this update data is not interesting for the application itself. This is important for the management of the device and firmware update of the device if a firmware update is requested. I can here click to see the history on the backend, and I can see here that the reset request was sent, then the device sends a so-called bootloader request, then erasing of first page was requested. This is acknowledgement of the action, and then this is the first chunk of data, and it continues like this until the end. And the firmware update is being performed like this. We can theoretically check what's the state of the updates. I think it's in, if I'm not wrong, should be here. We'll check it. Yeah, so we are at step 17 after some time. Normally it's something around 150 or 180 approximately messages which is exchanged. So maybe we will fast forward in this part. Okay, so now you can see that the device is booting, and because I use the stock firmware without modification for this SIM card which I have there currently, it boots, and it should not be now able to send any data to the backend because it will, he's sending data, but it is ending in a black hole. This is the report of the reset which happened. You could see the printout in the console. So it basically tells the backend what was the std out before last reset, and now it is sending a beacon message, but you will see that it will not arrive because using the firmware update I burned their stock firmware, which is not modified to use an internet UDP communication. So that's the proof that the firmware update really happened. I actually bricked the device. Yeah, the modification is here. The multi-mode script, as we call it, was modified to use to prevent IMSI information to send it to this port and this IP address of the backend. But the original state, the stock state is something like this, and it contains 20 without IMSI and this port, so it's communicating inside a private APN here. But I'm now using an internet SIM card, so you can see that he's waiting for answer, but no answer is coming, and he's retrying the communication. Okay, so this demonstrated how the firmware update works, that it works, and how it can be used with the backend. Thank you for watching, and maybe I will, before ending, we could look closer. No, I will kill the service. We could look closer to maybe the keys, but really what you only need for the connection is this key. Then you need to have settings in the Docker Compose to have the IP address of the server, which is here, and the port, which may change depending on how we together agree. And the rest is quite straightforward. Okay, so thank you for watching, and goodbye.